Can someone else share? Or you can check in the code and you can take a look. And I can share on my end. Where's let me bring up my Eclipse. Or you can send me the file on Slack, and then we can take a look.
I think I just reported it in through Eclipse. I just made a new QRemote XML file under the command model, under the UTC command.
Okay. Let me get the latest and. Starting up for me. So you were doing the modeling, right? A modeling piece of the puzzle. There's also another stream we need to start with the actual parsing piece of it, parsing and generation.
Yeah.
I think we can split the team in two halves. One team looking into the modeling, and the other one doing the Java piece of it.
All right.
So did we start on that?
We have not started talking about that yet. It is on our mind. What we had planned for was like just trying to deal with all the command models with all the models before our design day, and we wanted to work on the railroad diagram generator at first. But I'm fairly certain it's flexible, so if instead of doing the railroad generator, we could shift focus to the parser instead.
Yeah, we could do the command generator rather than the railroad generator first, right? So at least we have some commands that we can run from our model.
Okay.
So I think that'll be a better thing to show rather than showing someone that we can generate a syntax. The command that
Okay.
actually run and create objects on MQ or something, right?
Yeah.
So I think that's the more interesting. We need all of the pieces eventually, but I think that's for at least if we shoot for one module for design day, I think that's a module we should shoot for. So at least if we can demonstrate that, okay, here's when that got generated out of our models, and we can actually run it and create some MQQs, for instance, or channels. That'll be interesting.
Okay.
Okay. And the date, the design day is 26th, right?
I believe May 26th. That seems a bit far.
April 26th.
Okay. I'm losing all sense of time.
Okay, I got something delivered. Changes. forgot. Do you guys do the recording, or should I turn on the recording? Refer back to it.
I think Jarrell or Jason should be recording. Are y'all?
Yeah.
I'm recording.
Okay.
Okay. So I need to start the recording then. Okay. Can you see my screen, by the way?
Yes.
Okay. Accepted your changes. Which project was it? This,
It should be under the UTC CMD command module model all the way down to the Q. I started a QRemote.xml.
okay.
And my question comes with, where did I put it? It's near the bottom. Under the attribute scope, the scope options cell is only supported by certain operating systems that are able to run the remote queue message. So I was just wondering if we would need to change the generic schema in order to deal with this, because there are a bunch of references and footnotes under each command that have very specific things for each command.
Let's see how far we need to get to those nodes, right? So QRemote is the one we're dealing with, right? And save it over here as a RD file, so it's easier to refer to. Just double click and open it, right?
Yeah, I think I put one.
Create QRemote is there. Okay.
Yeah, I think I put that in there.
Okay, cool. So which one?
It should be under scope.
Scope, right? Control F.
This is. I think I might have looked at a different version of MQ, but I think the point still stands because under right now I'm looking under IBM MQ version 8 define Q remote, and there's a footnote on scope cell note 3 that says it's only valid on Unix, Linux, and Windows. So I don't know what the overlap is between, the define Q series message and their supported commands and specifically Q remote's supported OS.
Yeah, I'm trying to get to the.
Is the thing. That's the page I'm looking at right now.
I don't know why it's giving me error message. Maybe something's going on with that site. Okay. Searching for whatever reason. Hey, where's the scope?
It should be near the bottom, right after. It's on line 70.
Here's scope. Okay. Scope is Queue Manager and Cell, right?
Yeah.
Okay, let's see what it says. Cell, I think, only exists on ZOS. So this could be valid only for Unix.
Linux systems, and Windows. So that's that also falls, I feel like, under the supported OS. So I don't think it's too big of a fix to take the supported tag, I guess, per message and then put it under each attribute.
Oh, I see what you're saying. So inside scope, there's a queue manager, which is an option, and another option called cell. And within that, there's some support for different OS.
Yeah, and even the default value, the scope queue manager attribute, it's not valid on ZOS. So we would need to have that available to us, I guess.
Okay, here's the thing. I've never seen this attribute being used in all the scripts that I've seen so far.
Really?
With MQ for probably 25 years now. So
Oh, wow.
I'm sure it's used in some project somewhere in this world. So what I'm thinking is, how much time do we want to devote to this one parameter? Let's see, if it was a problem with this parameter, a transmit queue is a very, very important parameter. It defines which queue, well, whether it's a transmit, actually, where is the transmit queue where the message goes to, which actually needs to be routed to a remote queue manager. So this is a very, very important parameter. What is the name of the remote queue on the remote system? Extremely important. Without these, the whole definition is invalid, right? Scope is not that important of a parameter, so I was thinking what to do with this.
I just wanted to point it out because these notes are everywhere, and I don't know, or are everywhere on virtually every single one of these railroad diagrams. So I feel like eventually we're going to run into something that's going to be more important than, I guess, scope.
Yeah. I thought this whole scope business was only for ZOS. Not valid for ZOS. Okay. I guess and scope is for ZOS, and there's another scope parameter. You know what? Let's do this. Things that are not so important, and it's giving us some pain. Let's do this. Just don't worry about the supported operating system. Just put scope and queue manager and cell as two options, and then we can put a note or something in there saying that please look into the documentation or something like that, right?
Sure.
So let's go back here. Oh, this is did we have something for notes or something in there, in the schema?
I don't know about notes.
We have a field for description.
We had a reference, but what?
The label.
Another description field that describe what the attribute does.
the description of the attribute, right?
Yeah.
Yeah, that's slightly different. Different than this reference, right? So this is what the attribute actually does, and then this is the reference, which we were sticking in all these notes if we need it. So let's add a reference to this, and for like this, which is hardly ever used parameters, we'll just say please refer to the documentation for OS support or something like that.
Okay.
Right, so I just added the attribute down below. This is what level actually? This is at the attribute, right? Okay, yeah, that should do it. See what I'm saying? So let me fix this and say, rather than going so far detailed, we'll come here and say reference. Okay, we're done. So you have two options, right? Cell and yeah. If we come across something like this, which is important enough to capture, then we'll do that. Then we'll have to look into it again. Okay, Ike?
Okay.
So let's just.
All right.
Now. Yeah. We also don't want to over-engineer stuff which is hardly ever required, right?
Yeah.
So see, that solves that problem. Okay? So I'm going to check
All right.
Okay, there we go. What next? Anyone?
Yep. I have another question.
Yeah, sure. Go ahead.
Let me share my screen. Alright, can you see my screen? Hello?
Hello, yeah, I can.
Alright. So, for the define queue, and the alter queue local, so like, 1 second. For example, this attributes in alter queue local has no default options but in a defined queue local, it requires a default option for it. I think that's the other problem we need to solve in the model.
Yeah, so okay, so create is creating it, so it will always have something in default, right? So what def priority means is the default priority of the messages going into the queue. So say priorities are associated with messages from 0 to 10, right? So the higher the priority, you would like to process those messages before the rest of the messages, right? So that's what the priority is for. So say for instance, the messages are coming in 1, 2, 3. The first message has priority 10. The first priority first message has priority 5. The second message has priority 5, and the third message has priority 10. Okay. So when you're reading out of the queue, it's always FIFO. So first in, first out, right? So the first message coming in should be read first, but since there's the third message is higher priority, it should be read even before the first message because it has higher priority, right? So that's what this is defining. What is the default priority going into the queue? So if you look at the create, it's creating. Is it the create?
Yes, this is the define queue local.
Define, right? Okay.
Yeah.
So define is defining this with 0 priority.
Yeah.
So alt will obviously alt is altering that object, right? So that object will always have some priority set to it, and you're changing the parameter of that, right?
Okay. But in the model, should we specify a default in here?
Yeah. So keep that 0 as the default. That's what I'm trying to say.
Okay. All right.
It's valid. 0 being default is valid. Because
Okay.
the other one is just changing the attribute, right? From 0 to something else, or if you don't, and these are all parameters, right? Whatever values you want to change, that's the one you're bringing.
Oh, okay. I see.
Yeah. So create would actually define the default parameters. The create verb in our case is the right.
All right. Can you talk more about the command parser module, like specifications and requirements for it?
Okay. So see what I don't have much details inside the diagram, did I? Anyway, so basically what it is so you're creating command modules, and that will be used to generate multiple things. So the command parser, I think the way we've defined it in that design diagram. Let me go there so we're all on this. We can change the name if the name is where's the docs? Okay, let me start sharing the screen. Can you see the screen?
Yeah.
So what it's doing is it takes in the command model, right? It's validating against command model schema, right? So does the XML that you're providing to it, does it conform to the schema or not? If it does not conform to the schema, it's obviously going to fail, right? So you're going to throw an exception right away. It's not compliant with the schema. And you do that always as a good practice inside your code, so you don't end up having problems down the road when the schema itself is not matching, right? So, excuse me. So this is only for validation of the model, which should always match, because they can always validate it before you send it to the command parser, right? The other thing you need is the command format, right? So the command format of MQSC will be slightly different from, say, command line thing for, say, create queue manager command, which you type in the command line rather than sending it to the MQSC command processor, right? So every command will have a slightly different formatting, which is being defined in this command format. Okay? So if you have this and this, we should be able to generate the script.
Okay.
Correct? So that's the first thing I want to address. So I guess in this design, we had the command parser doing both. We can actually split it up. We can say, let's have the command parser do, or command script, we can call it script generator, and the railroad diagram generator. They can be two different classes that can be developed at two different times, right? Okay. And the other thing that we were talking about was how do we reverse engineer the textual stuff into the model. I have a wrong arrow here. It should go from here to the command model, right? Not the schema. Like this. We're not generating the schema, we're generating the model out of that railroad diagram or whatever, right?
You don't want to say questions on that.
And this is only for validation of, and this is very, very generic, right? You can also generate the schema for the command itself, which is not here, which we can look at later on. That's not important. So the next thing you guys need is this, be able to generate the script, right?
Can you hear it?
Yes.
Okay. And let's split this up. All this and railroad generator, or do we need command in front of every one of them? Generator and script generator. Makes it a little bit clearer. We can move it from here, here. So we have completely two separate modules. The reason I kept this together was because you'll be reusing this part in both of them.
Okay.
So you need to parse the command in order to be able to get to the script generation or the railroad diagram generation, right?
Yeah.
Yep.
Yeah. So there's a common module here, basically, to parse parse this. which is nothing. You can actually use the EH method to do it. So yeah, don't worry about it. Just keep them separate for now, and then eventually, if we group it together in different commands, we do that later on. Let's focus on the functionality of this for the time being. So let me go back and see if I ever got to the command format. No, I did not, right? So for you for the command format, and I'll create a format for this for MQSC. And then if you have questions, you can Slack me or something. So let me put that as a note. I'll try to do it today itself. These days are not stuck. Okay, so what else?
Is there an example of generated scripts we can take a look at it? Like the format of the generated scripts?
Okay, so the best thing to look at this moment is this project, UTC Java. Okay, it does generate script, but it does not use the command model, nor does it use the command formatting, right? So this is all new concept to make it more and more generic. What it did was something like this. Let me show you this class. And you'll see it's very, very basic. So we started this project as a requirement from a customer with a complex environment to be built. Right? And we did that as quickly as possible. So there's certain things which we didn't think of at the time. And then as things grew, obviously you had more and more complexity to deal with. And hence, we're now creating the model and the formatting, everything at a very generic level, so it can be plugged in very easily. But let me show you what it actually does today, which is very helpful as far as the functionality is concerned, but not ideal. Okay, so if you go through this code, most of it is just parsing through the so it's putting all this stuff into its own model, internal model hash. So this is a hash, which is defining a string and NQ clusters and all this, right? And here, so this is an example. So it's creating the MQSC script, and it's nothing but a file, writing bytes to a file. See how it's defining the queue local? Right? But see, it's using its own queue manager model inside. It's not really abstracted out to the level of a command model inside an XML. Change as you do it, but idea of what needs to happen. So this code obviously does a lot of complex stuff. So you create queue manager command is also generated and all this. And the complexity of MQ lies in the intercommunication between the queue managers, right? So the whole reason you'll use MQ is for messaging between multiple systems, and you can have 100 systems in different locations, and you want a robust way of sending messages from one machine to another machine. So how do you do that? If you do HTTP and the connection fails, what will happen? You'll just get an error inside your code that, okay, I couldn't connect, I couldn't send this message over. So what are you going to do with it? you have to resend that message somehow. So what MQ provides is a synchronous messaging platform, and so the application just puts the message into a queue, and it does not have to worry about all these network complexities and retries and all this stuff. So if the remote queue connection fails through the channel, it's going to retry internally, and the application doesn't have to worry about it. As soon as it's in the queue, it is guaranteed to be delivered to the other end if the configuration is correct, of course, right? So that's what it does. So all this intercommunication is obviously built into this and not separated out. So it's all over the place. But what you can very easily do see is how this command gets generated. So it's nothing but writing a string, right, to a file. And in our case, this is the verb, right? This is our object. This this bracket, this parenthesis, actually comes from the formatting. So you have to see what the formatting is, right, for MQSC when generating MQSC, and then put a code, single quote. So I'll have a boolean in there saying that single quote is allowed or not, right? So if it's allowed, you put the single quote. Then you take the name. This is the name of the dead letter queue, right? So that's going to be a parameter in the queue. Yeah. So take that name of the queue, and then depth persistent is one of the parameters, right? So from the message, you have to generate the command. Basically. Yeah, hold on one second. It's not actually from the model you're generating command, right? It's from the command message that you're. Hold on. Yeah, you cannot do that. Yeah, this is all grouped together. For the railroad diagram, you can you need the model. Okay, and for this, I'll pretty it up and send it to you. But this, you need the command message. Right. So what is the difference between the command message and the command model? The model actually defines all the parameters of that particular command, which complies with this schema. Now the command message is something like this. Right. This defines the group of attributes and stuff that needs to go into the command. So this will not have all the attributes in it, as opposed to the model, right? If you look at the model, it's defining how everything should be defined, whether you have defaults and all this stuff. This one does not. It's just defining what needs to be defined for that particular command. So you take this literally and convert it into this.
Right.
String. And this schema is also defined, right? Command message is also defined, yeah.
Yeah. So when we parse in our commands, we are using the command message instead of command model?
Yes, for the railroad, you need the command model, right?
Okay.
Because the railroad has the whole syntax of it. For this, so railroad definitely requires a command model.
Mm-hmm.
For this command message, you don't need the model, right? So you need to convert this script generated to the generated script.
Okay.
Right, so this is simple actually.
Yep.
And this requires the other schema, which is the we have two schemas. So we had the command model schema, and we have the command method. And this is what this guy should comply with. Right? So you need this schema, and you need to validate this message against this schema. Okay, so you take this, validate this message, generate this script. And also you need the formatting definition. Here, you don't care about the formatting, you're generating a railroad diagram, but you need the model schema, and you need the actual model, the command model, to be validated against the schema, and then this generated.
Okay.
Make sense?
Yeah.
Let me clean this up and I'll send it to you.
All right. Thanks.
Okay, so if you start writing the script, did we start on some Java code? Command parser. What I'll do is we need to integrate this with Enterprise Exception Handler, right? To handle exceptions and all this stuff. And if we go down below, this one actually does not use EH. If we go to the top, this was written before EH was written. So it has some exception handling of its own, but very similar to EH, but it's not EH. I think what this does is it uses this read config exception. So it defines its own, and it's similar, but it's different. However, if you look at the pure side of the world, this was written after we had, no, it's in the pure Java. Oh, package iPath. Okay, this starts off with the main program here. See, look at that. No. Long path. Okay. Okay, yeah, that's what I thought. This uses EH. This class itself is coming from EH. Okay. So there's a setup function that you have to do before you can call this validate XML inside this. So let me try to find that. Okay, so this is where it's setting it up. See this?
Yep.
Okay, so you need this line inside your code when you start off, right? So say definitely need this line here. Parser. Why do you need parser? I don't need parser. Yeah, this is pretty standard. You need to get to the log path and all this, right?
Mm-hmm.
Using 1.0.0 on exception handler. Can you? Oh, we need it. Actually, remove this. We don't need that class. Okay, that should get you started with the EH. Okay. Then,
Okay.
so once EH is set up, you can then use package iCast, right? So you can use something like validate XML. Okay.
Mm-hmm.
That's the name of the file you're parsing. Okay, so yeah, that should get you started. Okay, that should get you started with the code, right? And this is the function you'll use to parse. You send the file in, okay? And then you'll have to change this, of course. The schema is different, or it might be the same. So that's this. So it is different. So you get the idea. And this name is coming from inside this class. So that's the exception code, exception catalog name and version. And then you can use all these file not found and all these stuff inside it, inside this class.
Okay.
Sounds good. Once you start playing with it, you'll understand what to do. Big deal. But this is more or less already done. This part. So doc rather than system, you'll have md method, right? Right, and you can go from there. So this is already parsing out your whole XML just by invoking this one function. Plus, it has all the exception handling you want. So that's why we're using this this function inside exception handler. Okay. Sounds good.
Yes.
Cheers. Not being used, that's why it's complaining. finds these this and so on. Okay.
All right.
So start off with that code. You'll still need to do some work to even get started in the parsing and see if you can parse that file and all that, right?
Yeah.
Anything else?
So just a quick to-do list. Just start up the part.
Yes, let's do that parallelly because you'll need some work. Split into two teams. One looking to the Java part of it, and the other one looking at the modeling part of it.
All right.
Right? And that should do it. Okay?
That sounds good, Ron.
Okay, and if you have questions, just Slack me. Right.
All right. Will do. I think we're good for now. Yeah, we're fine. Yeah, Jason dropped his connection from the phone, but I think we're all good now. I just asked him if he had any questions, but he's okay.
Okay, sounds good.
Yeah, we got it.
All right, we'll see you next week, Ron.
Okay, let's keep moving with two streams of work, and then we'll talk next week.
All right, bye-bye.
Okay, thanks. Bye.
Oh God, where did it go?
So is the to-do list just to like keep going with definitions?
Yeah, make definitions, and currently you gotta do the parser too.
Yeah. Well, now that we have some definitions, we can actually do the parser, which is great because that means I can actually write Java.